balance.
At a big scale, the winds in Antarctica are kind of spinning in a big clockwise direction around the continent. But you can imagine a big dome of ice has very little obstruction, like trees or mountains kind of steering the winds. Consequently, winds that sort of are gravity-driven and come down the continent can build up speed really quickly and, again, uninterrupted by any sort of disturbance. And we call those katabatic winds. And they have a major influence on what happens at the edge of the continent. Around Antarctica, there's a massive current that we call the Antarctic circumpolar current, and it flows clockwise around the continent. Close to the continent, we also have the Antarctic coastal current, stays really close to the coastline and flows counterclockwise around the continent. In addition to these continent scale currents, we also have regional scale currents such as gyres. Gyres are these parts of the oceans that are sort of isolated because of topography or ocean bottom topography. They're usually closed currents that often circulate. The gyres have a big role in sea ice formation and also in the currents that actually flow underneath our ice shelves. You can imagine that around the edge of the continent, near those ice shelves, warm water from the ocean can intrude into that cavity and contribute to basal melting, the melting from warm ocean waters of the bottoms of our ice shelves. Calving in Antarctica is a little bit sporadic and it's hard to actually model, but some of the contributing factors associated with calving include those strong katabatic winds pushing on the edge of the ice sheet, pushing on the edge of the ice shelf and calving large ice.